Hey, I'm Adam and this is my lines of charge lab. The purpose of this lab is to find the electric force between two charged tapes. The system is the charged tapes and the surroundings is everything around them. This is very similar to lab 1, but in this lab we'll be estimating the charge as a line of charges instead of one point charge. And in the end of this experiment we'll find that estimating the charge in a line is more accurate than estimating the charge as a point. Some assumptions that we're going to make our life easier are we're going to say that each piece of tape has the same net charge and that the charge is evenly distributed along each piece of tape. We're also going to ignore air resistance. Some basic physics principles that we use in this lab are the force of the electric field, which is this equation, and Newton's third law, which allows us to say that the force of gravity is equal to the force from the electric field. Our initial conditions in this lab are that the mass of our tape was 0.00021 kilograms and that the distance between the tapes were 2.5 centimeters when they started to move, and that the charge of the tape estimated in lab 1 was 1.19 times 10 to the negative 8th coulombs, and we'll see this value has changed as we're estimating in a line of charges in lab 2. Here's the function that I made to calculate the charge of the electric field. You can see that it takes in a charged particle and an observation location and returns the charge of the electric field. This part of the code was given to us and it basically creates the model that we're going to use to visualize the charges on the piece of tape. This part of my code calculates the net electric field on the top tape due to the bottom tape. It iterates through each charge on the bottom tape and calculates the electric field on each charge on the top tape. Here's the model that my code created. The green arrows represent the electric force on each charge on the top piece of tape. The white arrow represents the net electric force on the top piece of tape, whereas the yellow arrow is the force of gravity on the top piece of tape. Notice how the electric force and the gravitational force are equal. Some important questions that we have are, what if you had modeled each of your tapes as a single point charge, like in the previous lab? And compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So in lab 1 we estimated the charge as a point, and we got a value of 1.19 times 10 to the negative 8th coulombs. In lab 2 we estimated the charge as a line, and ended up being 2.59 times 10 to the negative 8th coulomb. This value is approximately 2.18 times larger than the value we got in lab 1. Another question is, why do these estimates differ? This is because we're using a line of charges instead of a point charge. With a line of charges, we take many slivers of the piece of tape and see how it affects the many slivers of the top tape. The value that is more likely to be closer than the real value is the line of charges, and this is because the more charges that we use to estimate the charge, the more accurate we become. Some sources of error are going to be human error. That would come in when we were measuring the distance between the charged tapes when they started to move. This measurement was really hard to see because it kind of happened quick. Another source of error would be touching the tapes. With our hands, this would distribute the charges throughout our hand instead of keeping them in the tape. In conclusion, it is more accurate to estimate the charges on a piece of tape in a line rather than as a point charge. And thank you for listening to my lab report.